Okay, let's get started. My name is Krzysztof Pawłowski, and I'd like to share with you our experiences of developing fully serverless application in Java over the last year. Let's start with a few words about me. I work at Merapar in Gdańsk, where we help clients to transform to the cloud by designing and developing innovative solutions using AWS platform. I also teach students using good development practices at Polish-Japanese Academy of IT. I've spent my last 10 years developing in Java. I recently got interested in cloud solutions, and I'm trying to combine those two worlds together. So what we are going to talk about today, we'll start with explaining what the serverless is. Then I will tell you why we have chosen serverless approach and why we went for Java in our solution. And then we will move on to the lessons that we have learned while conducting this project. And I would like to finish this presentation with some of the best practices recommended by AWS architects when developing serverless solutions. So basically, serverless computing is a type of the computing where we don't need to provision the servers. We don't need to manage them, so we can just implement our business logic, deploy it, and then running of this logic as a code is handled by the computing platform. So let's have a look closer at the details how it works. So first, when you implement your function, which you want to run in a serverless environment, you need to put it to some kind of storage. In our case, because we use AWS, it was S3 bucket. So we put our jar file into S3 bucket. And then when the client wants to call our function, then the request is being sent to the serverless computing platform. And this computing platform will fetch the code from this storage. Then it will deploy this function on one of the underlying servers, which have some execution environment running on them. Then it will run this function and return the result to the client. So basically, most of the things is handled by the cloud computing platform. The developer responsibility is just to put the code, or in case of Java, jar file, to some kind of storage. And also define this function in the cloud computing platform. So how does it look like in Java? What is the server? What's the execution environment? So first we have EC2 instance, which is basically a server in AWS environment, where we have an execution environment. And currently it's OpenJDK 8 running on EC2 instance in the execution environment. And then we need to implement a request handler, which is basically the code of our function. And we can see that this request handler implements the interface from AWS SDK, which is request handler. And then we need to implement this method handle request, which will take some parameters as an input, depending on what we put as the generics here. And then we have code of our function. So that's as simple as that. You implement the function, deploy the code, put the code on some kind of storage, and then it's being handled. So what we were working on was a big migration project where we had to migrate several million of customers and devices to a new platform. So there were some challenges. The first one was that it was the user who decided whether he wants to opt in or opt out from the migration process to a new platform. So the consequence of that was that we couldn't predict the exact load at given time. So our solution had to be highly scalable to handle the peak load. Also, not only the users, but the data had to be migrated. So it required quite a lot of interactions with other services. And when the users were migrated and the data of the users was migrated to a new back office, we also had to trigger the firmware upgrade on the devices in people's home. So we were thinking how to best orchestrate this migration process. And we decided to go for this serverless solution, where we implemented a service called migration service, where the core of this service was AWS Step Functions. So AWS Step Functions is basically a service which helps you to define, enables you to define the workflow, because the migration is some kind of the workflow, and you can define the steps which needs to be taken in order to migrate the user. So we also use services like AWS Lambda for actually implementing those steps of the migration workflow. So this was the part where our business logic was implemented. Also, we use API Gateway for defining the endpoints. We use DynamoDB as a database where we kept migration status. And also, we use AWS Elasticsearch and Kibana for logging. And thanks to this setup that we used AWS, it was rather easy to integrate those components inside AWS Cloud, but also the interactions with other services from the old back office and new back office were rather easy. It was not so hard to configure VPN connectivity to the back office of the client. And also the connectivity with the devices was good because we were able to manage the networking for our project. So why did we go for serverless in the first place? First of all, we really like the idea that we don't need to manage the servers because it wasn't something that we would like to spend time on. So after first 2 sprints, we were actually able to deliver a first solution which maybe didn't do much, but at least we had the migration workflow defined. The customer could see what are the steps, how it looks like. We could do short demo and gather initial feedback. So actually providing some initial developed product was really easy. Also, we liked about AWS that the deployment process was simplified, and also packaging of the whole stack was easy using AWS CloudFormation. So this is the service that enables you to deploy the components built using AWS services in one step. Also, what I mentioned before, our solution had to be highly scalable, and we didn't need to architect against this because it was already provided by the serverless services from AWS that we used. Also, because we knew how many users we need to migrate, we more or less knew how many requests there needs to be done. So because you pay mostly, in most cases, per request at AWS, it was rather easy to calculate or estimate the overall cost of the migration, which was also important for the business. And again, we wanted to prevent from such situation that user opts for migration, wants to have a new platform, but then he cannot use his device for some period of time because our service would be down. So we had to make sure that our service is highly available and fault tolerant. And again, because we use serverless solution, which was managed by AWS, we got it out of the box. And why did we go for Java? Because if you look at some statistics, about 70% of Lambda functions for AWS are written in Python or Node.js. So it might not look like a natural choice to use Java for your serverless solution. So the answer might be a little bit trivial, but the main reason why we went for Java in the first place was that those were the competencies that we had in our team. We are all Java developers. We really wanted to use the well-tested and well-known by us libraries like Apache HTTP client. In my opinion, strongly typed languages are much better for complex solutions, and our migration service was rather complex project. Also, AWS provides you with really well-documented SDK for Java, so it was really easy to integrate with AWS services using AWS toolkit. And also, we really like that we can still use our favorite IDE, IntelliJ IDEA. We could use still Maven for the building process. So we wanted to prevent from the situation that we would need to learn new stuff about the architecture, which is brand new. Serverless approach is not so, it's quite fresh, and we didn't want to learn a new language as well. But when we've chosen that we want to have a serverless architecture, we knew that we will be developing the code in Java. then the first lesson that we had to learn was what should be the project structure. Because previously, if you had microservices, you have a jar file per microservice, that's easy. But here, the granularity is even bigger, and we have functions. So should we put all the functions into one big jar file, or should we have a jar file per Lambda function? So that was the first question that we had to answer. And there are, of course, pros and cons of each of the approaches. So for one big Maven project, it's easier to build because there is only one output. We can also reuse the code because it's one project. But the drawback of this approach is that there's longer time needed to actually download and unpack the package before the invocation. So this is what we could see on the first slide, on one of the first slides where we could see how the cloud computing platform works. And if we would go for project per Lambda function, then we will have the benefit of single functionality deployment. So there's a good code separation. We make sure that if we modify one Lambda function, then we don't break other Lambda functions. But it can lead to code duplication. Now that AWS Lambda Layers are available, we could have tackled this problem differently. But at the time that we started developing the service, they weren't available. OK, so I've told you that we don't need to manage servers. We don't need to provision them. So we can focus on developing the code, the business logic. But that's not fully true. The complexity is still in there, but it has moved. So where has it moved to? To explain this, let's have a look at the endpoint definition in Spring Boot application. I guess that most of you use Spring Boot or Spring or other web applications framework in Java, and they are more or less the same. So here we can see that we have annotations saying that this will be the post request, that the response status will be created, everything's fine. We have also response body, which in this case is simply a long value. And we have also path defined in the code. And then there is a body of the method, and we can see what it does. In this case, it's creating just one resource. So if we would like to do a similar thing in AWS, then we need to get to know at least 3 services. The first one is AWS IAM for managing users, roles, and permissions. Then we have AWS API Gateway, which is used for defining the endpoint. And then we have actually this Lambda service for running our code. So the complexity has moved from a single code base to multiple services. So there is a little bit more work to start with creating an endpoint. So let's have a closer look at how we would do this in AWS in more details. So first, we implement AWS Lambda Handler, which is basically the method that I showed on one of the previous starts. We need to implement request handler interface. So you can see that it's basically almost the same as what we could see in this example from Spring Boot. But it's only the first part, and we can see that we are missing annotations here. So we don't have a definition of path in this place. We don't have all the responses defined, and so on. So we need to also define another resource in API Gateway service, where we need to provide JSON definition using Open API, also known as Swagger, definition of the endpoint. And there we need to put all the responses, all the errors, mappings, and so on. So basically, we need to start with documenting our thing. Of course, if we are developing Spring Boot application, we should take care of the documentation as well. But here, if you want to start doing that, you need to start with the documentation. You need to have it done properly. But that's not all. Also, when you have your Lambda function defined, when you have your endpoint defined, you need to make sure that your API Gateway endpoint can run the code using AWS Lambda. So you need to give a permission to API Gateway to actually execute your Lambda function that you define in AWS Lambda service. And here you can see the example of such a permission. So there are basically 3 steps to achieve the same thing that we could achieve in Spring Boot in just a few lines. So this is something that we need to keep in mind, that now, when we are moving to serverless world, we need to take care as a developers also about the infrastructure, about the platform. We need to have knowledge about the platform. So it's easier then to deploy because we have everything running in production-like environment, but the initial development might be a little bit harder. Okay, so now one may say, okay, if I need to set up 3 components to actually run my code, so what about debugging or troubleshooting of my application? So it might be a little bit disappointing, but there is no such thing as remote debugging of your Lambda functions. You cannot attach debugger from your IntelliJ to Lambda function running on AWS. It's not possible because of the security. Don't have access to those servers where your code is running. But you have something else to help you. So there is a tool called AWS SAM, which stands for Serverless Application Model, where you can run your Lambda functions locally. So this application simulates AWS services on your machine. But when we started implementing our solution, there was no yet support for step functions. So we had to actually test our Lambda functions in isolation. We had to know what would be the input for the Lambda function that would be given by the step functions, and then test this. Also, recently, AWS released an IntelliJ plugin where you are able to debug your Lambda function locally. So there is a Docker container starting with the execution environment, and then you have access to you can attach your debugger to this code. So let's have a closer look at this IntelliJ AWS toolkit. So when you install that in your IntelliJ, then you have a new project type called AWS Serverless Application. You can choose the region where you would like to test your solution later on, so you can actually deploy it on the cloud later on. So here we can see that there is an additional thing called here that you can debug your Lambda function locally. You can also run your Lambda function locally. So it helps a lot, and then you need to provide input for your Lambda function. But if you look, when you tested your function locally, you debugged it, you know that it's running properly, then you can actually run it remotely on AWS Cloud. And it's a huge help because before that, you had to package your function into a jar file, you had to upload this jar file, and then run your Lambda function in AWS using, for example, command line interface. So this tooling made your life much, much easier. But before you start debugging, maybe the wise approach would be to actually look at the metrics and logs to see what happened. So what we really like during the development of our application, and also then testing and running it, is that AWS provides you with a lot of metrics that will help you to monitor your application. So you can see on this slide a dashboard, which was possible to define in just a few seconds, in a few clicks. So we could have information about how many workflow executions were started, how many of them failed. We just get it out of the box. Also, and this is from AWS CloudWatch service. Also, a really nice service is AWS X-Ray, which simply builds the map of your application, so you can see all the interactions between the components from AWS that you're using. So for example, our Lambda function was calling DynamoDB database, so we can track what are the interactions, how many requests there were, what was the average time of request. We could also trace the single request to see what was the timing, and this tool helped us a lot when we were investigating the issues with the performance of our application. So it's again a powerful tooling that you even don't need to configure. You get it out of the box if you are using the clients from AWS to actually call AWS services. Other thing, which is really nice, is that you have also a dashboard for logs in AWS. So in AWS CloudWatch service, you can browse, search, and filter logs the same way that you could do this in Kibana. But still, if you prefer to use Kibana, you can configure Kibana for your application in AWS. And again, it's fully managed by AWS. So again, you don't need to care about provisioning servers or maintaining them. OK, so now we are going to, I think, most interesting lesson. What is the performance of Java code in AWS? So when we were making this decision if to go for Java, we also had these considerations: will it behave correctly if there will be some performance issues? Because most people are using other languages for such approach. So we ran a test based on simple application, exposing get endpoint and returning just hello world response when calling this get endpoint. And we ran this application in Java environment, Node.js, C#, F#, Go, and Python. We ran all those applications with 1 GB of memory. And important information here is that cold start is not taken into account. I will explain cold start effect in Java in just a few moments. So let's have a look at Java code performance inside Lambda function. So it's just execution time of Lambda function, not the endpoint itself. It's not a response time. So we made this test firing 10 requests per second, and we calculated the average time over a period of 1 minute. So we can see that maybe it's not fully visible, but Java is this green line on the graph. So we can see that it doesn't have the worst performance, neither it has the best one. So it's in the middle, but it's not like it's outstanding in a negative way. So we were still fine. We knew that we can live with it. What about the maximum duration of Lambda execution over a period of 1 minute when firing those 10 requests per second? So Java, again, is a green line. And we can see that Java behaves really consistently. So we can see that this line, I put it in the other graph as well so that we can see only line for Java on the below part of this slide. You can see that it behaved consistently over our test. And with other languages, it was not so obvious. We could see some of the spikes. And now we are going to the endpoint itself that I described before. So we can see that now Java is red line. So we can see that Go language is still the worst in this case, but for other languages there is not so much difference. Still, the average performance of all those endpoints written in different languages is more or less the same. And Java is still quite consistent here. And the same for the maximum latency. We can see that, again, Java endpoint has a consistent performance. The line is more or less flat. Whereas for other languages, it could differ a little bit. So we can see that this integration of API gateway and Lambda function written in Java works quite good for Java language. OK, so that was the first step. I said that we make those measurements using 1 GB of memory. But when you are defining AWS Lambda definition, then you can set up how much memory you would like to assign to your execution environment. And depending on how much memory you assign, then more memory means more CPU power. And you pay for each started 100 milliseconds of execution time, and the price depends on the memory that you allocate. So now we have quite hard task to find what is the best configuration, because you can go up with the memory, and then the execution time will be significantly lower, and as a result, you will pay less, even though the price is higher for a bigger amount of memory. So you need to find the sweet spot where the setting will give you the best performance for the lowest cost. So we used an open source tool called AWS Lambda Power Tuning. You can find this on GitHub, which basically runs a state machine that would test your Lambda function in different configurations. So here you can see that there are a few configurations from 128 megabytes of memory allocated for your Lambda function up to 1 gigabyte. And then you can define how many repetitions you want to have. And then the output of this application is the report. So in this report, you can see those green fields is that it's the best price. But we can see that the price is the same for 128 and 256 megabytes of memory allocated. But the execution time is almost 2 times faster for the second configuration. So we would definitely go for this 256 megabytes of memory allocated. If you increase the memory further, then you don't gain so much on performance, but you pay a lot more. So we knew that it makes no sense to allocate more memory to our Lambda function because the gain is not significant, but the cost is much higher. Okay, so regarding the performance, there is such a term like cold start for serverless applications, and we've learned that it might be an issue in Java. But let's start with explaining what the cold start is. So when you run your Lambda function in AWS cloud, then first step is downloading the code. Then the execution environment is started. Then the runtime is being bootstrapped, so JVM starts, all the classes are loaded, and so on. And then your code is being run. So those first three steps are actually the cold start. And then we have warm start, which is just running the code. And cold start and warm start combined is total execution time. But why cold start? So we can see that if we start the Lambda function for the first time, we can observe that the execution time indeed consists of this cold start and warm start. So it's the cold start part and also the running code. But when we trigger the Lambda function for the second time, then we can see that only the part of running our code is being executed. So basically, cold start is first execution of your Lambda function where your execution environment needs to be set up for your code. But can it start later on? Of course it can. So if the interval between triggering your Lambda functions is higher than 20 to 45 minutes, then AWS would kill your execution environment. So with next execution of your Lambda function, the execution environment needs to be started again. Yeah, so AWS doesn't reveal the exact value after which the execution environment is killed, but from empirical experiences, we can see that it's between 20 and 45 minutes. But is it the only case where we can experience a cold start? No. Also, when we have concurrent Lambda executions, then we can see, like on this example, that when you have one Lambda function running and the execution hasn't finished yet, and you trigger another Lambda execution, then you will see that new execution environment will be set up. So you need to keep in mind when designing your serverless solutions that cold start is not only the first execution of your Lambda function. Yeah, it's every execution after some period of time and also every concurrent execution. Of course, in this situation, we have 3 execution environments being up and running. So then we can again start 3 Lambda functions and we won't experience cold start for those 3 Lambda functions. So why is it so important for Java? So when you look at dynamically typed languages like Node.js or Python, you won't observe much difference between the cold start and warm start. But in case of Java, where JVM needs to start, where all the classes needs to be loaded, it might take even a couple of seconds. For example, in our Lambda function, where we had some database connection initialization, it could take even 8 seconds. So it's quite a long time, and it's not acceptable for the systems that require low latency. And also, if you have bigger jar file, then the cold start is also longer. So going back to the first lesson about which project structure we should choose, this might also have impact on this decision, because if we split Lambda functions into small files, then we will decrease the cold start issue. So how can we decrease the cold start time? First thing that we can do, and it's easy, we can increase memory. Then we have more computing power, and then the cold start should be shorter. But the drawback of this approach is that you will pay more. Also, in the end, if you are still not happy with the results that Java code provides you, you can consider going for other dynamically typed language. We did it for this Lambda function that took 8 seconds because it was an issue for us. And the easiest way to solve this was for us to rewrite this Lambda function into Python. And can we eliminate the cold start time? So we can try with such an approach that we will pre-warm Lambda function. So we'll call the Lambda function every 20 minutes to keep it warm. We can define some cron job for that. And one might say, OK, but still you need to pay for this. But the cost is not an issue here, because assuming that you allocate the most memory that you can allocate, which is 3 gigabytes, and you will be running for a year this Lambda function every 20 minutes, and this execution time will be 1 second, you will pay about $1 for a year. So it's not a huge cost. But what happens when you have n concurrent executions? Then you need to trigger at the same time n concurrent executions to keep n concurrent execution environments warm. So again, then you need to estimate what will be the load of your application. And then you lose this scalability. Again, when someone else will call your Lambda function the very same moment that you are pre-warming your Lambda functions, then this guy will also experience cold start issue. So you cannot fully eliminate the cold start here. You can just minimize that in this case. Other thing that was introduced by AWS recently is AWS Lambda Layers, which help you build the layers of your Lambda functions, like you have layers in Docker image, where you can add some libraries, dependencies, but also using those Lambda layers, you can define your custom runtime, which means that you can resign from using the OpenJDK 8, which is default one for Lambda functions. You can build your own execution environment. And here's the example of the project where GraalVM was used as the virtual machine for running the code, and Vertex for handling the Lambda functions. So actually, GraalVM is a polyglot virtual machine that starts up really quickly. Also, Vertex is a toolkit for building non-blocking reactive applications, and it's by definition really fast. So using this solution, you can run your Lambda functions with minimal cold start time. But again, drawback of this solution is that you are using your custom environment, which is not supported by AWS. So you need to consider if it's OK for you when you are designing the architecture of your solution. Other option for handling the cold start is simply do nothing. So as I said, we had to rewrite one Lambda function because this endpoint had to have low latency. But for others, because the migration process was anyway quite a long process, we didn't need to care about the latency, especially that it wasn't like this latency would be experienced by every user every time. It was only when there were no migrations before in the period of 20 minutes, and because we wanted to migrate many millions users, so our Lambda functions should be warm most of the time. So the easiest solution is to do nothing if you don't need to do it. So you shouldn't try to solve this at every cost, because as you could see in the previous slides, it takes some time to develop the solution that would minimize or reduce the cold start time. Okay, and now we are going to the last lesson that we'd like to share with you. So the lesson is to understand and use AWS best practices. So for other libraries, frameworks, sometimes you can perceive those best practices like someone's opinion how you should write code, what is nice and what is not. But in case of AWS, those practices, those recommendations are really practical and will help you a lot and will help you to avoid a lot of problems. So first one is to take advantage of execution and context reuse to improve the performance of your function. So what does it mean? So as we could see on the slides before, that this cold start part contains bootstrapping of your environment, of your application. So when you initialize database connection or HTTP connection in your Lambda function function code, because you might think that, yeah, anyway, it's a separate, isolated execution. It's not a service its own. So you might be tempted to put everything in your function code. And this is wrong. You should always make use of the fact that the execution environment is warm for some period of time, and you should always initialize those connections to database or HTTP connections as a static field in your class or a singleton, and you should not create long initialized objects in this handle request method. It's generally a good approach when you're developing any application, not only serverless, but in case of serverless application, you will experience the consequences really quickly, and it will cost a lot more. Other good practice is to use AWS Lambda environment variables to pass operational parameters to your function. So going back to the example of Spring Boot application, there we have a YAML file with the configuration of your application, so you don't need to redeploy your application if some configuration needs to be changed. It's a little bit harder because here you have one jar file that is being put on the storage. So how can you easily modify the configuration of your application given that you don't have access to the execution environment? So for this, you have environmental variables, which you can modify from AWS console level. So you can log into AWS console. You can see your Lambda definition. And there you can modify the parameters, the configuration for your application really easily. And next execution of your Lambda function will take those parameters from this execution environment, and your Lambda is reconfigured. So it's really easy, but you need to take care of this while developing your Lambda function. You need to take the configuration from environment variables instead of some config file, which would be then embedded in jar file. Also, what is really important when you're developing AWS serverless solution is to get to know AWS Lambda limits. Because one might get the idea that AWS is scaling up into infinity, that everything is being taken care for you, but still, when you're architecting your solution, you need to be sure that you don't exceed the limits. So you have the limitation of concurrent executions of 1,000. So if you want to run many Lambda functions currently, you need to be aware of this limitation. Also, the function timeout is 900 seconds, which means 15 minutes. So if you have an application that is processing some data and it can take more than 15 minutes, then probably Lambda function won't be the best fit for your problem. Or you can change the design so that you split the data so it can be handled in this period of time. Also, you can allocate up to 3 gigabytes of memory. So again, for some big processing, might not be the best approach. The function environment variables size, maximum size is 4 kilobytes. So this configuration that we were talking about a moment ago, it cannot be bigger than 4 kilobytes. So if it's the case, then probably you need to think about putting this configuration into, for example, S3 buckets, so storage or database. And also TMP directory for your Lambda function has maximum size of 512 megabytes. So Lambda is not good for all the cases. You need to make sure that the solution that you are designing, which you are architecting, takes those limits into consideration. So going into conclusion, so is Java good for serverless? Definitely yes. So the only issue that we could see was with the cold start time when we wanted to have low latency of our endpoints. So it might be an issue, and then maybe you should consider if Java is the best language for your problem. And yeah, is Java always good for serverless? Definitely not. Yeah, so if you need to have low latency and the performance is really crucial, then probably you should think about other languages for serverless solution, because as you could see, there are ways to overcome this issue, but they require some work. It always question if it's worth it. So when should we use serverless? We should use serverless when we have unpredictable load of our application. So in our case, where we had this migration and we couldn't predict how many users will go for the migration at a given time, it was really good approach because we didn't need to take care about setting more instances during the peak hours. It was all managed by the serverless execution environment. Also, if we have low load of the application or we want to prove our concept or our business idea, then probably it's also good to start with Lambda function because the cost will be low. And also, we should not use serverless if we have long running processes because we have this limitation of 15 minutes. And when should we use Java in serverless? I already gave this answer to this question. If the latency is not crucial for us and cold start won't be an issue for us, then we couldn't observe any other problems with using Java. So if you are Java developers, and I guess you are because it's Java conference, then you should not be afraid that you need to learn a new programming language like Python, Node.js to start working with serverless solutions. So as I said at the beginning, I'm from Merapar, from Gdańsk. We are hiring. So if you want to do fancy stuff in AWS Cloud, then reach out to me or just write to us. I think we've run out of the time. So if you have any questions, then I will be around. So please approach to me and ask. Thank you very much.